My name is MOHSIN Ali, group number 15, and we are discussing here fog computing, IoT and cloud. The IoT has surpassed all the predictions made about it and is generating an unprecedented amount and variety of data. But with the prevalent cloud architecture, by the time data reaches the cloud, the opportunity to act upon that data might be gone. A new approach for analyzing and acting on IoT data is termed as fog computing or edge computing. This basically is an extension of cloud, bringing it to the edge of network. Main highlights: analyzes the most sensitive data on the edge near to the device generating that data instead of sending it to the cloud. Acts on IoT data and responds within milliseconds based on policy. Sends selected data to the cloud for storage and historical analysis. Why fog instead of cloud? To fully reap the benefits of IoT, one requires a new kind of infrastructure. Unfortunately, prevailing cloud models are not designed to handle volume, variety, and velocity of data that IoT generates. Also, with the exponential growth of devices being connected to IoT, there arises the problem of providing bandwidth required to move data generated by these devices for analysis to the cloud. Also, things in IoT can be varying types in which not all might use the IP protocol, which is essential to move their data to the cloud. Also, the analysis of the data being generated must be rapid, and cloud exposes the threat that opportunity might be lost by the time data travels to the cloud from the edge.
My name is Sajjad. Requirements not met by cloud. Minimize latency. Milliseconds matter when you are trying to prevent manufacturing line shutdowns or restore electrical service. Analyzing data close to the device that collected the data can make the difference between averting disaster and a cascading system failure. Conserve network bandwidth. Not all data needs to be transferred to the cloud because not all kinds of data require cloud scale computing. Address security concerns. Data produced by a IoT needs to be secured both the times when it is in transit and when it is resting in the cloud. Collect and secure data across a wide graphic area with different environmental conditions. IoT devices can be distributed over hundreds or more square miles. Devices deployed in harsh environments such as roadways, railways, utility field, substations, and vehicles might not be ruggedized. That is not the case for devices in controlled indoor environments. Move data to the best place for processing. Which place is best depends partly on how quickly a decision is needed. Extremely time sensitive decisions should be made closer to the things producing and acting on the data. In contrast, big data analytics on historical data needs the computing and storage resources of the cloud.
My name is AHSAN and I'm going to continue what fog computing is it. The approach that makes use of the underlying principle that the ideal place to analyze IoT data is near the device producing it is called fog computing. The fog extends the cloud to be closer to the things that produce and act on IoT data. These devices, called fog nodes, can be developed anywhere with a network connection, on a factory floor, on top of a power pole, alongside a railway track, in a vehicle, or an oil rig. Any device with computing, storage, and network connectivity can be of fog node. Examples include industrial controllers, switches, routers, embedded servers, and video surveillance cameras. Analyzing IoT data close to where it is called minimizes latency. It offloads gigabytes of network traffic from the core network, and it keeps sensitive data inside the network. Figure 2. The fog extends the cloud closer to devices producing data. Data center cloud, fog nodes, IoT devices. How does fog works? Developers either port or write IoT applications for fog nodes at the network edge. The fog nodes closest to the network edge ingest the data from IoT devices. Then, and this is crucial, the fog IoT application directs different types of data to the optimal place for analysis. The most time sensitive data is analyzed on the fog node closest to the things generating the data. In a Cisco mart, grid distribution network. For example, the most time sensitive requirement is to verify that production and control loops are operating properly. Therefore, the fog nodes closest to the grid sensors can look for signs of problems and then prevent them by sending control commands to actuators. Data that can wait seconds or minutes for action is passed along to an aggregation node for analysis and action. In the smart grid example, each substation might have its own aggregation node that reports the operational status of each downstream feeder and lateral. Data that is less time sensitive is sent to the cloud for historical analysis, big data analytics, and long-term storage. For example, each of thousands or hundreds of thousands of fog nodes might send periodic summaries of grid data to the cloud for historical analysis and storage.
My name is Faraz Shah. Benefits of fog computing. Extending the cloud closer to the things that generate and act on data benefits the business in the following ways. Greater business agility. The right tool developers can quickly develop fog application and deploy them where needed. Machine manufacturers can offer mass to their customers. Fog application program the machine to operate in the way each customer needs. Better security. Protect your fog node using the same policy, control, and procedure you use in other party of IT. Better security. Protect your fog node using the same policy, control, and procedure you use in other party of your IT environment. Use the same physical security and cyber security solution. Deeper insight with privacy control. Analyze sensitive data locally instead of sending it to the cloud for analysis. Your IT team can monitor and control the device that collect, analyze, and store data. Lower operating expense. Conserve network bandwidth with processing selected data locally instead of sending it to the cloud for analysis. Benefits of fog computing. Extending the cloud closer to the things that generate and act on data benefits the business in the following ways. Greater business agility. With the right tool, developer can quickly develop fog application and deploy them where needed. Machine manufacturers can offer mass to their customer. Fog application program the machine to operate in the way customer needed. Better security. Protect your fog node using the same policy, control, and procedure you use in other parts of your IT environment. Use the same physical security and cyber security solutions. Applications. Fog applications are as diverse as the Internet of Things itself. What they have in common is monitoring or analyzing real-time data from network connected things and then initiating an action. The action can involve machine-to-machine communication or human communication interaction. Example include locking a door, changing equipment settings, applying the brakes on a train, zooming a video camera, opening a valve in response to a pressure reading, creating a bar chart, or sending an alert to a technician to make a preventive repair. The possibilities are unlimited. Thank you.